Byron Bay Railroad Company searched the country and found a dilapidated vintage train called a Red Rattler and spent $4 million to restore it and get it up and running, including another $1.8 million on restoring the 3-kilometre disused rail line. Plus a further $1 million was spent on the train shed and 2 platforms at each end. The 2-carriage rail set was constructed in Sydney in 1949 using aluminium, which made them very lightweight. On its roof, the train boasts 6 kilowatts of custom-made flexible solar panels and are backed up by 77 kilowatt hours of battery storage, which has taken the place of one of the train's 2 original diesel engines. The train only uses about 4 kilowatt hours for each one-way trip and has been able to make 16 trips and only use 25% of its onboard battery power, all without using any top-up charging.
to make the body train prototype. So first, for the body train, we use the reusable food container and we covered with the old cardboard. For the tire, we take from old remote control car and the reusable battery holder, and the last one, the motor that we use also we take from the old RC car.
Today I will explain about how the process making of the prototype train. For the body part, we sketch and measures to let the other component fit well in the prototype. So at the front of the body, we use the cutting bottle to get the cap of bottle as the aerodynamic of prototype. So here is we create a hole as a passive cooling system, which is called ventilation system, and here is the windshield. We use a cap of container. At the bottom of the body, okay, we create a hole to let the gear fit well of the body. Okay, for the shaft, we using a skewer as the shaft wheels, and the straw we use as the cover shaft using a straw, and the wheel is we take it from the RC car. After the body is completed, we arrange the electric component inside the body, and the solar panel is at top of the body.
So now I'm gonna explain for the electrical part. So as we know, we are using solar for the train, and we have passive cooling, which is pure natural airflow. But I'm gonna talk about the electrical part here. So we are using solar, which we buy from hardware, and then we connect it to the battery holder here. As you can see, there's a black wire and red wire connected to the battery holder, and then from the battery holder goes to the control board inside. The control board has a switch to switch on and off, and then from the control board it will go to the motor. So you can see inside there's a wire, and for extra we have an LED that we take from the recycle RC old car, and then the motor will drive the gear to the drive shaft for the tire here. So if the motor move, the tire will move. So solar will charge the battery. Actually it's gonna be rechargeable battery, but we don't have the budget, so we use normal battery. So from the battery we'll power up the control board, and then from the control board we switch on, and then the motor can run using the remote that we have here. It's on, but it doesn't move right now. So yeah, that's all.
So here I'm going to explain about the functions of our product. So first we start with solar energy. Solar is to capture the solar energy, convert into electrical energy. Second is rechargeable battery. Rechargeable battery is stores the energy generated by the solar panel for consistent power supply. Third is control board. This is control board. Control board is to regulate the power flow from the battery to the monitor, ensuring stable operations. Fourth is motor inside. Motor is for convert the electrical energy into mechanical energy to drive cooling mechanism of move to the train. Lastly is tire. Tire is for provide the mobility for the trains by transmitting motor power to the track. So we made this hole for passive cooling. Lastly, passive cooling. For passive cooling is we choose natural airflow to cool the motor.